The diagram shows part of the line and curve. Okay, the point P lies on the line and the point Q lies on the curve. So let's look at this. So point P, the x coordinate is r, so I know that this is going to be r as well. How? I can just put it into this because P lies on the line, and then Q also having the same x coordinate, which is the r, but now it's lying on the quadratic curve, so I'm going to get r6 minus r here. So they are saying the x coordinate both is r. Okay, done. And r is between 0 to 5. Why is it so that r has to be between 0 and 5? Simply because, you see, what is this intersection point? We know that this definitely going to be 6, and of course its origin here based on this. You know, if you equate that to 0, you will get 0 and 6, like in this format. And then if you want to find what is this, you take the line and equate to the quadratic curve. So that's how I'm getting the 5. So this value is 5. So they are saying the r can range from 0 to 5, and that makes a lot of sense. Now they said express h in terms of r, and you find the greatest, it means the maximum value of the h as the r changes. So how do we do this? So where is our h? H is here. So h is simply r, 6 minus r minus r. Find the gap, that's the h. Done. Now I need to find the maximum value of the h. So greatest indicates dh, dr, it's going to be 0. So our r value is 2.5. So how do I know it is going to be the greatest? To verify this, you can do the second derivative. Which is negative 2, sorry, it's from here, yeah, less than 0. Therefore, h is definitely maximum. Now let's look at question B. In question B, it's showing a rectangular field, okay, and then the lengths are all given, a lot of description, and then they ask us to show that the area of triangle APQ. So let's see what happened. What is this? This is 80 minus 2x, and this is going to be 50 minus x, because the length here and here is similar, same, and AD is equal to BC with that logic. But now I'm only interested with this portion here. I only want this area. So what can we do? We find the area of the rectangle and we minus the area of triangles. And how many triangles I have there? I have 3 of those. So 50 times by 80, that's going to be 4,000. Okay, I'm going to do this first, second and third. Half times base times height. So half times 50 is 25. Then half times 2x is x. Half times 80 is going to be 40. So it's just 40x. So let's simplify. Okay, shown. Now as x varies, of course x can change. We don't know what is this. It's a variable. They say find the stationary value of the a. So they want you to find the value of the a, and they have given that stationary. The keyword stationary is given. So what are you going to do? You know at stationary point, we know dA dx. Your variable here is x, right? It's definitely 0. Okay. And now I'm interested with the stationary value of a. If in a stationary point, if you have x and here a, this is what we call as the value. So they're asking you to find the value of the a. So just substitute 20 squared. Okay, that's the area value, and we have to check whether the area is going to be maximum or minimum. When x is equal to 20, will the area be maximum or minimum? Let's check. To check the nature, you're going to do the second derivative. Value is greater than 0. So what can you conclude? Your a is minimum.